Assalamu alaikum everyone. So today we are going to start paper 2 AS level chemistry. It's 970122 October number 2024. So let's move to the question number 1. Vanadium, niobium and tantalum are metals in the same group of periodic table. The shorthand electronic configuration of vanadium in the ground state is argon and the leftover electron are written as 3d3 4s2. Till argon we have 18 electrons. What is meant by the term ground state? So if they ask you about the ground state, so it is the state in which the electrons are in at the lowest energy. So you are going to write that it is the lowest energy state of electrons. Now, show the electronic configuration of vanadium using electrons in the Voxis notation. So see, we have 2 electrons in 4s and 3 electrons in 3d. So if you label it, this is 4s and this whole thing is these 5 orbitals belongs to 3d. So in 4s, you are going to fill a pair of electron because there is a one orbital and you have 2 electrons over there. In 3d, there are 5 orbitals and we have only 3 electrons. So we are going to fill each electron in each orbital. If you remember, we fill all the orbitals first with 1 electron each. When all the electrons have all the orbitals have 1 electron, then we are going to make them pairs. Now, next part, deduce the total number of electrons in the p subshell of vanadium atom. So that is just 3d. Okay. Okay, they are asking for the p. So if you see, till over here, there are 18 electrons and there are 5. So 18 plus 5. So in total, there are how many electrons? 23 electrons. So the atomic number of vanadium is 23. So if you write the electronic configuration from the start, it is going to be 1s2, then 2s2, then 2p6, then 2p6, then we have 3s2, then we have 3p6. So after 3p6, we have 3d3 and 4s2, right? So if you see 6 electrons over here and 6 electrons over here, so these are the electrons of the p subshell. So 6 plus 6 makes it 12. So there are 12 electrons in the p subshell. I hope it's understandable to all of you. Now, next part. Fallopium was suggested the name for new element discovered in a mineral. Fallopium was later found to be a mixture of a niobium and tantalum. Okay, so fallopium is not actually a metal, but it's an alloy which contains 2 metals, 2 elements. Only one naturally occurring isotope exists for each niobium and tantalum. Complete table 1.1. Okay. So here you go. They have given you the symbols of the niobium and tantalum along with their, you know, uh, nucleon number and the number of protons. So the smaller value is proton number. So it is niobium has a 41 proton and tantalum has 73 protons. Now neutrons can be identified by subtracting these two values. So can anyone subtract it? 93 minus 41 and 181 minus 73. So in the first case, if you subtract 41 from 93, so 2 and 9, so it's going to be 52. And over here, is going to be 8. Yeah, it is going to be 108. Is this clear to all of you? Okay. Now, define the relative isotopic mass. Okay. Yeah. So they are not asking for the relative atomic mass, they are asking for the relative isotopic mass, right? So it is the mass of an atom of an isotope, or you just can write that it is the mass of an isotope compared or related to the 1/12 of the mass of carbon 12. Uh, yeah, carbon 12, you have to mention that it is either carbon 12 atom or carbon 12 isotope. Okay. Now, a sample of palladium contains 90.9% by mass of niobium and 9.1% by mass of tantalum. Calculate the theoretical relative atomic mass of palladium based on these data. Give your answer to 2 decimal places. Okay. So we have to calculate the mass of palladium. So if we are comparing the palladium as a whole, so its relative atomic mass is going to be equal to percentage abundance of niobium times its isotopic mass, which is 92.91. Then percentage abundance of tantalum, which is 9.1 times its relative isotopic mass, which is 180.95. And then divided by 100. Can anyone solve it quickly and tell me the answer, please? Yes, can anyone calculating the values, please? Yes, is anyone calculated the value? Okay, 90.9 times 92.1 plus 9.1 times 180.95 over 100 is equals to, yes, I'm getting 100.192. So the relative atomic mass of palladium is 100.92. Okay. Now, question number 2. Oxygen is a group 16 element. Write equation for the following reaction: sodium and oxygen, sulfur and oxygen. Okay. So if we react the sodium with the oxygen, it will form sodium oxide. So sodium has a +1 oxidation number, oxygen has a -2 oxidation number. So the formula is going to be Na2O. So to balance the equation, You just need to put 2 over here and half over here. The equation is balanced. Otherwise, you can put 4 before Na and 2 before Na2O. The equation would be balanced in that way as well. And the second one is sulfur is reacting with the oxygen. When you react the sulfur with the oxygen, uh, one minute. Yeah. So first it turns into sulfur dioxide. So you are going to put SO2. Now, part two, draw dot and cross diagram to show the species present in aluminum oxide. Draw outer electrons only. So for outer electrons, okay. So aluminum turns into +3 ion and oxygen turns into -2 ion. So you just write aluminum, an empty bracket, because the valence shell loses its all of the electron, square bracket, enclose it in a square bracket, and 3 positive. Then for oxygen, the valence shell, it has a 6 electrons of its own. So 1, 2, 3, 4, 5, 6, and 2 electrons were gained. And that's why it gets a -2 charge. So enclose it in the square bracket and put -2 as the power. Okay. Okay. Now, question number part 3. The maximum oxidation state of period 3 elements in their oxides varies across the period. Okay. State and explain the variation. So if you recall, when period 3, right? So we have a first sodium oxide where sodium is +1, then magnesium oxide Mg is +2, then aluminum oxide Al is +3. Then we have silicon dioxide where silicon is +4. Then we have a phosphorus 5 oxide where phosphorus is +5. And then sulfur trioxide where sulfur is +6. So see, the variation is that what is the variation? That it increases, right? And why it is happening? Because you see that the oxidation number is actually equivalent to the number of electrons in their valence shell. So as we move across, the number of valence electrons increases as the number of valence electron increases. Is this clear to all of you? Now, question number 2b. Water reacts with both inorganic and organic compounds. Complete table 2.1 to give details of the reactions of some period 3 oxides with water. Okay. So if we are getting magnesium hydroxide in table 2.1 with the reaction with water, so the oxide must be magnesium oxide, which is MgO. And magnesium hydroxide is partially soluble in water. So its pH is alkaline. So its pH of the solution is, and it's a weak alkali, so it's like 10. Okay. And then P4O10, when it dissolves, it forms an acid that is phosphoric acid, H3PO4. And as it's a strong acid, so the pH of a solution is around 1 or 2. Now, next part, 2. Write an equation for the reaction of methane nitrile with water in acidic conditions. Okay, so basically it's a hydrolysis reaction. So they make you confused by just writing it with water. So what is happening if you recall that nitrogen gets away from the carbon, and the carbon turns into a carboxylic acid because it's an acidic medium, and the nitrogen forms ammonium ion. So if you see, we got two oxygens, right? Two oxygens over here. So it means we need 2 moles of water. And how many hydrogens we got? Four over here and one over here, five. So four hydrogens coming from there. So only need to put one over here. Our equation is balanced. Is this clear to all of you? Okay. Now, part 3, draw the structure of the two alcohols formed in the reaction shown in equation 1. Okay, so it's a propene, right? Like, for example, if I draw its skeletal structure, so it would be like this when you are reacting with water. So the two possibilities is the one, the OH got on the first carbon or the OH got on the second carbon. So they ask you to draw the structure, so it there doesn't specify any structure, whether it's a displayed formula or a structural formula or skeletal formula, so you can go with anyone. So I am doing it with the skeletal formula because it's easier and saves time. Okay. Now, explain why alcohols are less acidic than water. Okay. So the simple thing is that if they are less acidic, it means that the strength of the OH bond, if the OH bond is weaker, then they dissociates to give you hydrogen ion and this ion. Same happens over here. It will give you this ion and hydrogen ion. So that is the acidic behavior. But if this bond is the OH bond is stronger, then it doesn't allow the alcohol to be a strong acid. It makes the alcohol to be the weak acid, and it is because of the alkyl groups. Water doesn't have any alkyl groups, so water easily break down into H positive and OH negative quickly as compared to the alcohol. So what alcohols do, they are electron donating in nature. The alkyl groups, sorry, are electron donating in nature. So when they donate the electron, as a result, the OH bonds get stronger and it doesn't break easily. So we can write the answer that alcohols have alkyl groups which are electron donating in nature. Hence, they make OH bond stronger. So if OH bond gets stronger, then it doesn't break easily, and that's make it a weak acid than water. Is it clear to all of you? Now, C part. Figure 2.1 shows the boiling point of water and other group 16 hydrides. Okay. Explain the trend in the boiling point of group 16 hydrides from H2S to H2TE. Okay. So from H2S to H2TE, there are uh, there are intermolecular forces or the permanent dipole-dipole forces. And as the number of electrons increases, so the strength of these increases, these intermolecular forces increases. So we are going to write from H2S to H2TE, the number of electrons increases. Okay. So the intermolecular forces of attraction between your molecules increases, and if they increases, so we need larger energy to overcome these forces of attraction, and which results in the increase in the melting point and the boiling point. Now, part 2, explain why the boiling point of water is much higher than that of H2S. So uh, it's for 1 mark. So the main reason, you all know that in water, between the water molecules, there are hydrogen bonding, right? So hydrogen bonding between the molecules and hydrogen bonding is stronger than the intermolecular forces between H2S molecules. So, is this clear to all of you? Okay. Now, question number 3. Nitrogen and phosphorus are the elements in group 15 of the periodic table. Nitrogen is found in inorganic compounds such as nitrogen oxides, nitrates, and nitric acid. Identify one natural and one man-made occurrence of nitrogen oxides in the atmosphere. So in the atmosphere, the natural occurrence of nitrogen oxide is due to lightning in the skies during the thunderstorms, and the man-made is due to the internal combustion engine. Okay, now part 2, write an equation to describe the role of NO2 in the direct formation of acid rain. So they're asking for the equation. So what they do, the NO2 reacts with the water and oxygen, and as a result, it turns into nitric acid, HNO3. So you know, you have to balance the equation. We are going to put 2 over here, which makes the even number of oxygens on the left side, which now the oxygens on the left side are 6. So 2, 2, and 2, right? So, and we have a 4 hydrogens on the left side. So I'm going to put the 4 over here, making the hydrogen balanced. But this makes nitrogen 4, so I'm going to put a 4 over here. So now if you count the oxygen on the left side, there are 8, 2, and 2. So there are 12 oxygens, and 12 oxygens are over here. 4 nitrogens are on the both sides, and 4 hydrogens are on the both sides. So the equation is balanced. So this is how nitrogen oxide directly act in the atmosphere to form the acid rain. Now, next part. Peroxyacetyl nitrate PAN is a component of the photochemical smoke. Describe how PAN forms NO2. Okay, forms from NO2. So what happens if you recall, there are volatile organic compounds which are also called unburnt hydrocarbons. So nitrogen dioxide reacts with volatile organic compounds, which we call VOCs, in sunlight. So this reaction results in the formation of PANS, peroxyacetyl nitrate, which causes smoke. Now, next part. 4. Nitric acid reacts with the basic oxides to form nitrate. Write an equation for the reaction of a nitric acid with calcium oxide. Okay. So that is a acid plus metal oxide reaction. So when a acid reacts with the metal oxide, what we will get? We will get salt and water. So water is here for a salt, calcium is +2, nitrate is -1. So make the formula, it will become CaNO3. Twice to balance the equation, there are two nitrates, so I'm going to put 2 over here. Now there are two nitrates on both sides, two hydrogen on both sides, one oxygen on both sides, and one calcium on both sides, except the oxygen in the nitrate. So the equation is balanced. Now, part 5. Describe what is seen when solid calcium nitrate is heating strongly. So if you recall, this heating, it decomposes to give you calcium oxide, nitrogen dioxide, and oxygen. And nitrogen dioxide is a brown gas. So as there is a brown gas, this liberates from the heating of a solid. So we are going to observe brown fumes. Okay, now part B. A common test for nitrates is the reaction of sodium hydroxide and aluminium. Equation 1 shows the reaction. So see, this is the reaction you have been studying from since your O level or IGCSE, that add as equals sodium hydroxide, aluminium foil, and heat the solution. Then ammonia gas forms, which turns the damp red litmus paper blue. So if this happens, so it means there is a nitrate. So see, this is the equation. Okay, which shows what reaction is taking place. Okay, reduce the oxidation number of nitrogen in NO3 negative. So if you work on NO3 negative, so the net charge is -1, oxygen is -2, and there are 3 oxygen, which makes it -6. So -6, it means nitrogen is +5. So +5 and -6, when we add it, we get the net charge of -1. So the nitrogen oxidation number of nitrogen is +5 over here. Okay. Now, part 2. Identify the species that is oxidized in equation 1. So the oxidized means the species whose oxidation number goes up. So nitrogen is +5 over here. And if you see nitrogen got -3 over here. So it means nitrogen is being reduced. If you see aluminum is an element over here, so its oxidation number is 0. And over here, it is part of the compound. So it means aluminum must be +3 over here because it's a metal and metal always loses the electron. So the species whose oxidation number is increased is aluminum. So aluminum is the species in the equation 1, which is oxidized. I hope it's clear to all of you. If anyone of you has any confusion in this, please ask. Now, part 3. Ammonia is a basic gas. Describe how ammonia is able to act as a base. It acts as a base by accepting
यार
a
आप
proton.
नाइट्रोजन क्यों नहीं लिखा?
Sorry,
आपने नाइट्रोजन क्यों नहीं लिखा? उसने भी तो इलेक्ट्रॉन्स लूज किए.
nitrogen gained the electron. See, it changes from
हाँ
+5 to
गेन.
-3. So
सही है.
nitrogen is reduced.
हम्म.
Understood? Yes, Abdullah.
यस सर.
Okay. So ammonia is able to act as a how? So any base is the species which accepts the proton. So ammonia can accept a proton, and whenever we are talking about proton, we are referring to the hydrogen ion. So ammonia acts as a base because it accepts a proton. It can have ability to accept the hydrogen ion by losing its lone pair, right? Now, next, suggest the shape of this ion. Okay. So if you work on this, aluminum has only 3 electrons in its valence shell. So there are 4 OH bonded to it, and obviously aluminum has 3 electrons. It means that aluminum has a 4 bond pair right now and 0 lone pair. So if this is the case, when you have a 4 bond pairs and 0 lone pair, then the shape of the molecule is going to be tetrahedral. So if this is an ion with the central atom having a 4 bond pairs and 0 lone pair, then its shape is going to be tetrahedral. I hope it's clear to all of you. Now, figure 3.1 shows a sketch of some of the ionization energies of phosphorus. Okay. Construct an equation part 1 to represent the third ionization energy of phosphorus. So For a third ionization of phosphorus, phosphorus must be in a +2 ion in the gaseous state, and it is going to turn into +3 ion in the gaseous state by losing the electron. So that is the third ionization energy equation. Now part 2, complete the graph in figure 3.1 to show the third to sixth ionization energy of phosphorus. Okay, so if you just write phosphorus, the atomic number is 15, so it means 1s2, 2s2, 2p6, 3s2, and 3p3. So the first three electrons are going to be removed from 3p, right? So it means that the third electron is also, these three electrons are removed from 3p. Then these two electrons are removed from 3s. Then these are removed from 2p, right? So next electron is also going to have a same difference. Then the electrons are removing from 3s. And then the next electron is removed from 2p. So it would be like this, because 2p from 3s to 2p, when we are moving, there is a big change because the shell is being changed. So you have to draw the dot over here, which shows a significant difference between the fifth to sixth, which shows that the shell is being changed, that the fifth electron is removed from 3s, and that's why it has some sort this much energy, and the sixth electron is removed from 2p. So there is a big energy gap which you need to show. Is this clear to all of you? Okay, now B part. Complete table 3.1 to show the properties of nitrogen and phosphorus in their standard states. Okay, so they have initially, in the first one, state and appearance. So they have mentioned this state of nitrogen is colorless gas and the phosphorus is white solid. Electrical conductivity, both are non-metal. So the electrical conductivity of nitrogen is also going to be poor, right? Okay. Then the type of bonding, so both are non-metal, so they usually undergo covalent bonding. The type of structure, so both are simple molecular because nitrogen is diatomic and phosphorus is P4. So both are simple ones. Is this clear to all of you? Now,
सर कभी कभी वो टाइप ऑफ बॉन्डिंग करके जो है वो भी पूछ लेता है कि इसके अंदर sp बॉन्डिंग है या फिर sp2 बॉन्डिंग है तो वो कैसे डिफरेंशिएट
oh,
करेंगे हम?
hybridization. They ask you the hybridization. That is not the
ओके।
bonding. A form of solid nitrogen has a lattice structure similar to solid iodine. Identify the type of lattice structure of solid nitrogen. So iodine is also a simple molecular lattice. So if there is a structure of iodine is solid, so that solid is also going to be a simple molecular lattice because there are molecules with a covalent bonds, and between the molecules there are intermolecular forces which are holding them to form a lattice. So it's a simple molecular lattice. Okay. Now, part F. At very high temperature, phosphorus can form P2 molecule. P2 contains a triple bond. Describe a formation of triple bond in terms of orbital overlapping. So see how the orbitals overlap. So if there is a triple bond, if you recall for a nitrogen, one pi bond and two sigma bonds, so it means that atom is sp hybridized, right? So you see there is a triple bond, so it means there is a one sigma bond, right? And there are two pi bonds. So if there is a sp hybridization, so sigma bond is always formed from the overlapping of the hybrid orbitals, and hybrid orbitals overlap, direct overlapping, they undergo, or a head-to-head overlapping. So one sigma bond, and it is formed by due to head-to-head overlapping of sp orbitals. two pi bonds, and pi bonds are always formed by the sideways overlapping of the p orbitals. So, or you can either write parallel overlapping. So sideways overlapping of p orbitals which are unhybrid. Okay. Now part two, the bond energy of phosphorus triple bond is 485 kilojoule per mole. The bond energy of nitrogen bond is 944 kilojoule per mole. Compare the reactivity of phosphorus and nitrogen. Explain your answer. So which one needed less energy to break their bond? The P triple bond P is much weaker as its bond energy is less. Hence, P2 is more reactive than N2. Remember, the one which needs, whose bonds are stronger will not break easily, so it will not undergo a reaction quickly. The one with the lesser bond energy is going to break their bonds easily and will undergo a reaction quickly. Okay. Now, okay, we have a question number 4. Bromoalkane are used widely in industry, although there is increasing concern about their environmental impact. Figure 4.1 shows the reaction scheme involving 1,2 bromoalkane. Okay. So initially we have ethane and it is reacted with the bromine. So it's an electrophilic addition because the double bond is broken and both the carbons get one bromine. And this reaction occurs at room temperature pressure, if you recall. Now, when we react with aqueous sodium hydroxide for this reaction, reflex is needed. And this is a nucleophilic substitution. So what happens? Both the bromines get substituted with OH. In reaction 3, C, NaOH in ethanol, and we are getting a bromine, and the carbon on the neighboring carbon of a bromine is eliminated. So it's an elimination reaction. Okay. And they are asking for the name of this product. Okay. So it is going to be named as bromoethene. In the reaction 4, it is turning into a polymer C. So C, you just make the single bond to the carbons which has the double bond, put the rest of the groups above and below, and then empty bond. So it is the one repeat unit of the polymer C. So it's a polymerization reaction. Then B is reacted in a excess NaOH in ethanol. So if we are using excess NaOH, so the as one bromine and the hydrogen gets eliminated. So with the with the excess NaOH, another bromine and a hydrogen is also eliminated, forming the two carbon just with the triple bonds. So it is also an elimination reaction. Okay. Complete figure 4.2 to show the mechanism for the formation of 1,2 dibromoethane in the reaction 1. Include charges, dipoles, lone pairs of electrons, and the curly arrows as appropriate. So see, it's a addition reaction, right? Electrophilic addition reaction. So what happens if you recall, this bromine gets a partial positive charge, this bromine gets a partial negative charge. Then from this pi bond, there is a curly arrow over here, and the curly arrow from this bond to this bromine. So as a result, this bromine turns out to be a bromide, and we got the two carbons with a single bond. And out of these two carbons, one carbon got the bromine and the other carbon becomes the carbocation. Now, this bromide ion with the lone pair attacks on this carbon, and as a result, we will get our this product. So it's very easy, actually. Put the double bonds, put the curly arrows, partial dipoles, lone pair, and the whole chart is. Okay. Now, B part, the enthalpy change for reaction 1, delta HR is minus 90 kilojoule per mole. Okay. The enthalpy change for the formation of ethene is positive 52.2 kilojoule per mole. Calculate the enthalpy change for the formation of 1,2 dibromo. Okay. So, if you see the enthalpy change for this reaction is, if you see, minus 90 kilojoules per mole. They have given you the enthalpy change of formation of ethene. So if it's a formation of ethene, so it means 2 moles of carbon when reacts with 2 moles of hydrogen. This is formed, and that is the enthalpy change of formation of ethene, and the enthalpy change for this is 52.2. And they are asking for the enthalpy change of formation of 1,2 bromoethane. So it means that they are asking when these elements combines and turn into this, what will be the enthalpy change? So that is X. So if you look at the cycle, this directly turning into this first turning into this, and from this turning into this. So this is your indirect route and this is your direct route. So it's very easy that this plus this is equals to this. So you got the expression that positive 52.2 plus minus 90.0 is equals to X. And if you calculate the value of X, X is equals to minus 90 plus 52.2. So it is going to be 37.8 in negative. So negative 37.8. Is it clear to all of you? Now, C1, complete figure 4.1 to draw the structure of a compound A, name compound B. So, the structure of a compound A, we have already identified. The name of compound B, we have already identified, right? Okay. Now, draw the structure of one repeat unit of polymer C in the box. So that's what we have already did. There are two carbons with a single bond. One carbon is going to have a two hydrogens, one above, one below. The other carbon has a one bromine and a one hydrogen. And we are going to leave the two empty bonds on both the sides. Now, part 3, in reaction 5, compound B reacts with excess NaOH dissolved in ethanol. The products are HBr, H2O, and then unsaturated hydrocarbon D. Identity of D. So if you see the identity of D, we have already identified that there is a two carbon molecule with a triple bond, right? So you can draw this H with a carbon, then a triple bond, then carbon, then H. Or you can just write its molecular formula, which is C2H2. Because they have just asked you the identity. Okay. Now, part D, compound E is the only isomer of 1,2 dibromoethane. Okay. Alkaline hydrolysis of E gives a compound F. Okay, so that is a compound E, which is the isomer of that 1,2. So that is 1,2 dibromoethane. So this is one isomer, and the E is another isomer, and E on hydrolysis turns into an aldehyde. Identify the type of isomerism shown by E and 1,2 dibromoethane. So if you see, this has two carbon, and carbon 1 has one bromine and carbon 2 has one bromine. Over here, the carbon 1 has both the bromine, carbon 2 doesn't have bromine. So the position of bromine actually different in both the molecules. So it is considered as positional isomer or position isomerism. Is this clear to all of you? Now, name the homologous series that F belongs to. So we have identified that C double bond O is bonded to a hydrogen only. So this homologous series is called aldehyde, right? Now, part 3, complete table 4.1 to state what is observed when F reacts with the reagents listed. So F is an aldehyde, Aldehyde when reacts with 2,4-D and pH, we know both aldehyde and ketone undergo reaction with this, forming orange PPT. F is an aldehyde. Aldehyde reacts with the tolerance reagent, and it will give you the silver mirror or the silver precipitates on the test tube or on the container, and sometimes do give you black precipitate as well. Alkaline iodine, so C, CH3, C double bond O, H. So this group is there. So yeah, it undergo the test with the aqueous alkaline iodine. So aqueous alkaline iodine, we are going to get a yellow precipitate because it has a methyl group bonded to a carbonyl. It's just neighbor to C double bond O. So we are going to get a yellow precipitate. Okay. Now, compound E, sorry, E part. Compound F reacts with the reagent G to form a compound H. Okay. The infrared spectrum of H is shown in figure 4.3. H is also shows a molecular ion peak at 60 in its mass spectrum. So C, it means it's the MR of compound H. Okay. Use the information in figure 4.3, figure 4.2 to deduce the structure of H. Explain your answer fully. Okay. So if you see over here, this peak, isn't it this peak 1600 to 1670 to 1740? And if you see this whole peak, isn't it this peak? Right? So it means compound H have a C double bond O, compound H has a OH. So it clearly indicates that actually G is an oxidizing agent like acidified dichromate. And as a result, this aldehyde actually turns into a carboxylic acid, ethanoic acid. Okay. So if it's an ethanoic acid, let's see how we will work on it. How we'll further justify it. So C first draw the structure CH3 C double bond OOH. Go for its MR. It has 2 carbons, so 2 times 12, 24. It has 2 oxygens, so 2 times 16, 32. It has 4 hydrogens, so 4 times 1, 4. If you add them, 4, 4, 8, 8 plus 2, 10. So 3 plus 2, 5 plus 1, 60. So C60. So the MR is going to be the same, and we are figuring out these. Okay. So we have identified the identity. Now we are going to explain it. Uh, we got a broad absorption of OH of C double OH at 2500 to, it's 2500 to 3000. Okay. Further, if you see, it has a C single bond O, and that range is 1040 to 1300. So C under 1300, we are getting this as well. Okay. Now, next, absorption of C double bond O at, and it is from 1670 to 1740. Right? Then absorption of CO at, and it was from 1042, 1300 centimeter inverse plus MR is 60. So these all are the evidence that this is the structure. Now, so this is the role of the reagent G. So if we go for the role of reagent G, so we have identified it. The G is actually an oxidizing agent. Is this understandable to all of you? So here we are done with the paper, and I think it's an easy paper. So, and I am hoping that your paper is also going to be easy, inshallah. So now we can do one more paper tomorrow, that is October, November 21 tomorrow. And if beside this you have any other further queries, so you can always approach me. Okay.
सर एक चीज थी। सर एक दफा मुझे आप रेडॉक्स इक्वेशन की बैलेंसिंग बता सकते हैं?